you with the snack calorie content of a snack food lab, since I'm not at school right now today. I like to have this turned in by tomorrow, but I wanted to just go over some of the math with you since I'm not there. But you're going to be using this major concept that heat lost by the snack food is going to be the heat gained by the water. And so simply just take the data from the water, the sea of water, the mass of the water, which is going to be your data on column 3, what was subtracted from the empty can of water to get the mass of water. So you're going to use the sea of water, the mass of water, and the change in temperature of the water. Multiply that together, and that's going to be joules, represent the joules of the food. And then those joule numbers should be in the thousands, okay? You're then going to take that number of joules and then convert that to, sorry about that here guys, convert that joules to calories, big C calories. So if you have thousands or 2,000, 3,000, you're going to be dividing it by 4,184, because that will bring it down to a certain number of calories. Once you have it into calories, big C calories, then you're going to be dividing the calories by the grams of the food that burned, okay? And this data is from the 6th column. There's several columns. I think there's 9 altogether. But you're going to be taking the grams of the food that burned, not the starting mass, not the ending mass, but what was left, what was the difference of the food that did burn. And that's going to be in your 6th column. You're going to take the calories, the joules you had, convert to calories, big C calories, divide it by the food that did burn. It's going to give you a unit of a calorie per gram. Okay? And this answer should be somewhere between 1.5 calories per gram to close to maybe 5 calories per gram. Okay? And then you're going to be calculating percent error. I wrote the equation on the paper to get that error, and then you actually have to compare it to the known calories per gram, which on most of the packages was 160 calories, and the mass of the potato chips in the bag was at 28.3 grams. So to get the known value, you're going to take 160 divided by 28.3, which is going to be about 5.5 calories per gram. That's going to be your known answer. What you're getting here yourself is your actual. So what you get in your data is actual. What the known is the numbers from the package. Okay? You're going to do percent error. When I get back to school on Friday, I can clear up any questions about the error calculation. Some of you guys might have 10 to 20. Some of you guys might have over 100. It just all depends on how well you got that final temperature recorded. Okay? Now, for your points on the grade for the lab, just to give you some tips on how you can get the maximum points, is that you want to show your work for at least one trial. Okay? You want to label all your final math answers. Like label calories, or sorry, label joules, label your calories per gram. Make sure you label all your final answers. I'll be taking points out for that. Then you're going to answer the first question with diagrams and with arrows to represent the flow of heat. So that first question underneath your final data numbers, when you draw that diagram, make sure you have some arrows to explain the flow between the burning the food into the water. And then your final answers of calories per gram, you should be rounding them to 2 significant digits. Also have it labeled. And then the final question, on question 2 at the end, you want to definitely have 2 ways that give us a lot of error. Not 1, but 2 ways that could be getting error for having such a high percent error. And also, if you could write in sentences on that last question, that would be awesome, okay, in terms of it being a lab grade, not an easy homework grade, okay? Again, if you have any questions, just text me on Remind, reply back to my Remind messages. If you have any problems or questions, I can try to help you tonight and then also in class tomorrow.